The story of the solar system's formation is a fascinating journey through space and time, one that stretches back approximately 4.6 billion years. To understand how the solar system came to be, we delve into the principles of astronomy, planetary science, and cosmology. This process, often referred to as the nebular hypothesis, is a tale of cosmic dust and gas transforming into the intricate system of planets, moons, asteroids, and comets we observe today. It all began with a massive molecular cloud, a cold, dark region in space composed of gas and tiny dust particles. These clouds are the birthplace of stars and planetary systems. The molecular cloud that gave rise to our solar system likely formed in the wake of a supernova explosion, the death of a nearby star. This event sent shockwaves rippling through the cloud, causing it to collapse under its own gravity. As the cloud collapsed, it began to spin. Conservation of angular momentum, a principle of physics, meant that as the material pulled inward, it rotated faster and flattened into a spinning disk. At the center of this disk, the material grew increasingly dense and hot, eventually igniting nuclear fusion and forming the proto-sun, the early version of our sun. The sun, now a glowing ball of energy, became the gravitational anchor of the entire system. The surrounding disk of gas and dust, called the protoplanetary disk, is where the planets would eventually form. Small particles of dust began sticking together through a process known as accretion, forming larger and larger clumps. Over time, these clumps grew into planetary embryos or planetesimals, the building blocks of planets. Gravity continued to pull these planetesimals together, and through collisions and coalescence, the rocky planets like Mercury, Venus, Earth, and Mars began to take shape in the inner part of the disk, where it was hotter. Farther out, where temperatures were much cooler, the story was different. Here, ices and gases could condense, allowing the formation of the gas giants Jupiter and Saturn and the ice giants Uranus and Neptune. These planets grew massive enough to capture large envelopes of gas, creating their thick atmospheres. Beyond Neptune, in the frigid outer reaches of the solar system, countless icy bodies formed what we now call the Kuiper Belt, where dwarf planets like Pluto reside. While the planets were forming, other fascinating phenomena were also shaping the solar system. Asteroids and comets represent the leftover building materials from the solar system's formation. Asteroids primarily inhabit the asteroid belt between Mars and Jupiter, while comets, composed of ice and dust, originate in the Kuiper Belt and the distant Oort cloud. These remnants provide valuable clues about the early solar system, acting as time capsules that preserve its primordial conditions. The early solar system was chaotic and violent, with collisions shaping the final structure. One such colossal collision is thought to have created Earth's moon when a Mars-sized body, often called Theia, struck the young Earth. The debris from this impact coalesced under gravity to form the moon. Similarly, the unique tilt of Uranus might be the result of a giant impact in its early history. Over millions of years, the solar system began to settle. The sun's powerful solar wind swept away much of the remaining gas and dust, leaving behind a relatively stable configuration of planets and other celestial objects. The gravitational interactions among these bodies also played a role in their final orbits. What makes the formation of our solar system particularly intriguing is how it aligns with what astronomers now observe in other star systems. Using powerful telescopes like the Hubble Space Telescope and the James Webb Space Telescope, scientists have detected protoplanetary disks around young stars in various stages of evolution. These discoveries validate the nebular hypothesis and provide a broader context for understanding how star systems, including our own, come to be. The formation of the solar system is not just a story of our cosmic origins, but also a blueprint for understanding the universe. Every rock, every planet, and even the water on Earth has a connection to this ancient process. For students of astronomy, this is a foundational topic that ties together principles of physics, chemistry, and planetary science. It reminds us that the solar system, while appearing timeless, is the result of dynamic and transformative processes. So, the next time you look up at the night sky, remember, you're seeing the culmination of billions of years of cosmic evolution. Our solar system is just one of many in the galaxy, but its story is unique to us, a narrative of dust becoming life, chaos becoming order, and a cold cloud transforming into a vibrant system of worlds orbiting a star. Don't forget to like, comment, and subscribe for more cosmic insights and the wonders of the universe.